Hello, my name is Jessica Edwards, and this is the final video for EDT 8210. In this video, I will be discussing cognitive load theory and the cognitive theory of multimedia learning. I will also be reviewing 3 ways to reduce extraneous cognitive load, including the signaling, redundancy, and spatial contiguity principle. Let's begin. The term cognitive load refers to the amount of information our working memory can maintain. When looking at cognitive load, we classify it into 3 types: extrinsic, intrinsic, and germane. First, intrinsic cognitive load refers to the complexity that is within an activity itself. Extrinsic refers to all of the information that is not relevant to the actual learning information. And germane is the effort that was put into forming the new knowledge. Cognitive load theory is based upon 3 parts of our information processing: sensory memory, working memory, and long-term memory, or schemas. The biggest issue with learning in our memory is that our working memory has a very small capacity for storing information. Because of this, our main goal is to eliminate any extra stuff that comes along with learning and focus on just the information needed. Our minds are an amazing thing. Without even realizing it, our brain takes in the world around us and forms schemas based on our experiences. We store these schemas in our long-term memory for future use. So, what part do these schemas play into learning? Using these schemas, we are able to develop an understanding of the objects around us based on our characteristics that we have encountered in similar objects in the past. We use these past schemas to help us in future situations by applying what we know about a topic to the new learning. Building off the cognitive load theory, researchers have developed a cognitive theory of multimedia learning. This builds upon the cognitive load theory by stating that learning is more efficient and profound when presented in a learning model that includes both pictures and words. In alignment with the CTL, the cognitive theory of multimedia learning's main goal is to reduce any extraneous cognitive load that may occur when using multimedia. In order to understand the cognitive theory of multimedia learning, we must know the 3 main assumptions when dealing with multimedia learning and cognitive overload. First, there are 2 main channels of processing: visual and auditory. These channels are separate and processed separately. Second, each of these channels are limited into how much information they can process individually. Third, learning is a constant active process that includes filtering relative information, organizing and integrating it based on previous knowledge. When learning is spread out through multiple channels, information does not compete with each other for processing. For instance, if you have a pictorial activity as well as a verbal activity, the brain will process these separately and thus minimize cognitive load. If you incorporate all text-based information activities, then that channel will become overloaded and minimal learning will actually occur. Okay, so now that we know the issues with cognitive load, let's discuss a few ways to decrease extraneous cognitive load and improve learning. First, the signaling principle refers to the concept that students' learning actually improves when the information is organized and cues are given to highlight the main ideas. This principle is one of the most important steps in developing multimedia content and can be used to reduce unnecessary information. It is important that information is presented in a way that allows the learner to focus on information in the correct order to achieve maximum benefit. By using signaling techniques, one can reduce extraneous cognitive load for the learner. For example, this picture here is an example of how to direct the flow of information. This picture is of a cell division. It is important that the learner knows the process the cell goes through in order to multiply. The arrows, as you can see, direct the learner's focus through each step of that development. If the arrows were not there, like in this picture, then it would be confusing for the learner to distinguish the flow of development. The confidence level of the learner will determine what information they notice first. Beginner level students generally focus on the more prominent text first. This can cause problems if the prominent information is not relevant to the subject matter, thus increasing the cognitive load. According to the cognitive load theory, we must decrease the cognitive load of our students to improve the learning. By displaying cues to feature the organization of the content, we can reduce the cognitive load and help learners understand the flow of information. Signaling can help decrease it by bringing the attention to the aspects of the image or the text that you wish your audience to focus on. This decreases the time the learner is distracted by any additional unnecessary information that may appear on the image or text. The next principle I would like to discuss is the spatial contiguity principle. This principle refers to aligning words to corresponding graphics. Basically, this means that a graphic that is being used as a learning tool should not be physically separated from the text. The spatial contiguity principle implies that words need to be closely aligned in proximity to corresponding graphics. This principle reduces extraneous cognitive load by limiting the extra step of finding which word or text is associated with the image. By placing the text closely or directly with the image, spatial integration can be achieved. This principle applies greatly in the healthcare field, where we are constantly using graphics and images for learning. For example, this image demonstrates one way to label a graphic or a diagram. Even though this diagram correctly identifies the parts of the brain, it requires the learner to associate both a word and a letter with each area. By adjusting where and how we label the diagram, we can minimize the extraneous cognitive load by eliminating that extra step. The last principle I want to discuss is the redundancy principle. Basically, what this states is that people learn best from graphics and narration than from graphics, narration, and on-screen text. Our minds involuntarily read text that is on a screen, so it is natural that if text is added to a graphic, then we will pay attention to the text, then the image. This image here describes what the redundancy principle is talking about. If I were to show this slide with both words and text, then in my narration I say, the brain is a complex organ that is in the major control network for all of the body's functions and abilities. That would be redundant because this is exactly what it says on the screen. A simple fix would be simply removing the text from the graph and then stating the fact about the brain. This will allow the learners to focus on what I am saying and associate it with the image rather than focusing on the text only. There are, however, some cases where it is appropriate. For instance, where there is no audio for an image, then naturally we must add text. On-screen text is also appropriate when there is not an image, diagram, or graphic. In any case, the text that is used should be directly related and relevant to the material that we are discussing, or provide supplemental information that the narration is not covering. Lastly, I want to talk about the use of refutation in learning. If you are not aware, refutation is the term that means to provide a statement that denotes an idea with contradictory points are made. This is used often in many different cases, but can be used effectively in the learning process as well. In the case of conceptual change, refutation can be used to discount a person's prior knowledge of a subject. It is often hard for a person to let go of what they think or believe to be true about a topic or subject. By using refutation, we can directly address the incorrect thoughts and replace them with the correct knowledge. One example might be the thought that ADHD is not a real medical disorder. So here's how you could use refutation in that example. You could say, although many believe attention deficit hyperactive disorder is not often a true medical disorder, extensive research by major medical, psychological, and educational organizations show that it is a result of imbalance of chemical messengers or neurotransmitters within the brain. By providing this statement, it directly replaces the prior thought and knowledge with the correct researched information. Using refutation within the learning process can help with conceptual change. In conclusion, we have discussed just a couple ways that we as instructors can help our students by limiting the effects on their cognitive load. The principles discussed were just a few of the many theories and principles that can be used. It is important for us as instructors to know that just by making a few instructional design changes, we can effectively reduce extraneous cognitive load. I want to thank you for viewing this video, and please keep checking back to my YouTube channel for more instructional design videos. Thank you.